Okay, let's dive right into this explainer. I want you to picture a Formula One pit crew. Just visualize it for a second. Every single second, actually scratch that, every millisecond counts. There is absolutely zero wasted movement in that pit lane. Every action is precise, it's practiced, and it's entirely targeted toward getting that car back on the track to win the race. Well, guess what? Your Cambridge Math exam, specifically syllabus 0606, is exactly the same scenario. You are in a high-stakes race against a ticking clock, and every mark is a crucial second saved. To really illustrate this, let's look at a real Cambridge Mathematics past paper question and analyze two hypothetical students. We'll call them Alex and Sam. Now, Alex is the kind of student who overloads their answer with raw, unfiltered mathematics facts. We've all been there, right? Alex is writing down every single formula they have ever memorized about circles, just dumping knowledge onto the page, but providing absolutely zero analytical direction. It's a mess. Sam, on the other hand, is completely panicking. Sam is rushing against the clock, completely missing the crucial command word requirements in the prompt, and just frantically throwing numbers onto the page, desperately hoping anything sticks. Both of these approaches lead to heavily flawed answers. You bleed marks this way. But today, right here, we are going to fix this. We are going to decode into exactly what the examiners want to see when you are asked to find the center and radius from complex circle equations. I absolutely love how structured this syllabus is. Think of our explainer today as 4 distinct, high-speed pit stops: decoding circle equations, securing method marks, critical examiner warnings, and finally, the success sequence. Let's get moving. Stop number 1, Section 1, decoding circle equations. Let's look at how building a conceptual understanding is your baseline for exam success. Now, this slide brilliantly illustrates the two formulas you are given. On the left, we have the standard completed square format. That's x minus a all squared plus y minus b all squared equals r squared. In this format, it's a dream, right? The center is crystal clear. It's just your coordinates, a, b, and the radius is simply r. It is beautifully, perfectly efficient. But then on the right, we have the expanded general form. This is x squared plus y squared plus 2gx plus 2fy plus c equals 0. This exact one is explicitly provided in your list of formulas. Here, the center is negative g, negative f, and the radius is the square root of g squared plus f squared minus c. Top-performing students, the ones hitting those top grade boundaries, they know exactly how to navigate between these distinct formats using systematic analysis. To truly master this, we are going to apply a framework that is usually reserved for writing essays in English, but it is highly, highly effective here. It's called the PEAL framework. That stands for Point, Evidence, Explanation, Link. For math, your point is explicitly identifying which of these two equations you are starting with. Your evidence is extracting the correct variables, pulling out your g, your f, and your c. Your explanation is the step-by-step algebraic manipulation, whether that is completing the square or substituting into the formula. And finally, your link is clearly stating the final center coordinates and radius with proper formal notation. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep building this system. Now, what's incredibly fascinating about this slide is that the theoretical architecture of these equations relies heavily on integration with other syllabus areas. You always need to look for those causal relationships. It's like a giant puzzle. For example, moving from the expanded form back to the standard form requires a flawless, and I mean flawless, ability to complete the square. That's a skill you learned way back in quadratic functions. Or think about finding where a straight line intersects the circle. That requires setting up and solving simultaneous equations. You see, examiners explicitly note in their reports that candidates who recognize these cross-topic connections are the ones who secure the absolute highest grades. Furthermore, when you are looking at these equations, you literally must decode the command words. If the exam question says, show that, listen to me, you cannot just write the final answer. You must show the entire complete algebraic journey, every step. If it says find, you have a bit more flexibility, but your underlying method must still be perfectly apparent to whoever is grading your paper. Moving on to Section 2, securing method marks. Cambridge examiners don't just want the final number. Let's explore how to actually capture those elusive M marks. Whenever you are extracting data or interpreting relationships from these complex equations, you must strictly follow these presentation conventions. This proves your professional procedural skills. Think of it like dressing up your math for a job interview. First, proper headings. If you are finding the center, literally write the word center and underline it. Guide the examiner's eye. Second, correct terminology. You need to intimately know the difference between radius and diameter and ensure you are taking the square root of r squared, not just lazily leaving it as the squared value. Third, appropriate formats. Coordinates absolutely must have brackets and a comma. If you write them without brackets, you are throwing marks away. Finally, clear annotation. If you are using the formula for the radius, write the raw formula down on the page first before you substitute a single number into it. This is your PL framework in action. By explicitly stating your formula, you instantly secure the first method mark even if your calculator slips up later. I want you to remember this method mark strategy forever. Let's transform those flawed, red pen-marked answers from Alex and Sam that we talked about earlier into beautiful, glowing green check marks. Let's do a live rewrite in our heads. We pull Alex aside and guide them to stop dumping random mathematical facts. Instead, Alex now writes, Step 1, identify G, F, and C. Clear, concise. Step 2, substitute into the radius formula. Perfect. Now we go to Sam. We guide Sam to just take a breath, slow down, actually read the command word calculate, and clearly show the completing the square process line by line by line, no skip steps. Examiners actively reward you for evaluating alternatives and showing your descriptive, analytical, and evaluative framework right there on the page. When you provide evidence-based reasoning, you are effectively communicating directly with the examiner. You are essentially saying, hey, I completely understand the underlying mechanics of this circle, and here is my irrefutable proof. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, Section 3, Critical Examiner Warnings. Let's shift gears and look at the insider secrets directly from the principal examiner reports, so you can avoid the traps that cost others dearly. This slide breaks down the top 3 reasons students lose marks. It proves that a lack of specificity and poor formatting can ruin an otherwise brilliant mathematical analysis. Let's look at warning number 1, confusing cause and effect. In circle equations, this almost always looks like a student incorrectly manipulating the negative signs when pulling the center coordinates from the completed square bracket. Here's a classic mistake. If the bracket says x minus 3, the x-coordinate of the center is positive 3, not negative 3. Warning number 2, forgetting to check format and presentation. Imagine leaving a radius as the square root of a negative number because you messed up your substitution on the previous line. If you don't stop and realize that a physical radius absolutely cannot be a non-real imaginary number, that shows a massive lack of format checking. You have to reality check your answers. And warning number 3, providing answers not specific to the given context. Listen, if the question asks for the exact radius and you plug it into your calculator and give a rounded decimal instead of leaving it in its pure surd form, like root 17, you immediately lose the final accuracy mark. I want you to read this alert very carefully. The examiners are practically begging you to define your mathematical terms before you deploy them in your working out. What this means in the context of our 0606 syllabus is pure clarity of thought. For example, if you are calculating the distance between the center of the circle and a line to prove that the line is a tangent, state exactly what you are calculating. Literally write the words distance from center to line equals right before you start your arithmetic. Doing this guarantees clarity and it shows the examiner exactly what your intent is. To overcome these extremely common pitfalls, top-scoring candidates employ a specific type of cognitive processing to guarantee their approach is completely bulletproof. We call this evaluative thinking. Now, evaluative thinking in mathematics might sound a bit strange, but it's absolutely essential. It means looking at your final equation. Say you have x squared plus y squared plus 4x minus 6y minus 12 equals 0, and quickly, rapidly questioning your assumptions. Did you actually have the coefficients of x and y correctly to find your g and f values? Did you remember that the formula for the radius subtracts c, meaning a negative c becomes a positive in the discriminant? Justifying your decisions with evidence means writing down the formula from the formula booklet before substituting. It literally takes 2 seconds of your exam time, but it acts as a massive cognitive safety net. And this builds perfectly into Section 4, the success sequence. This is where we take all of these examiner insights and turn them into an actionable step-by-step methodology. If you follow this exact 5-step sequence every single time you face a circle equation, you will systematically process the data exactly how the grading rubric demands. No exceptions. Let's do a high-speed interactive workshop right now. Challenge 1, the data scan. You have 60 seconds on the clock and then exam. Imagine this complex math equation pops up. 2x squared plus 2y squared minus 8x plus 12y plus 6 equals 0. What is the core trend? What's the trick here? Look at the coefficients. They are 2. Step 1 of our sequence says identify key elements. You absolutely must divide the entire equation by 2 first to get it into the standard general form of a singular x squared plus y squared. If you didn't do that, your g, your f, and your c are all instantly wrong, and the rest of your working is useless. Okay, challenge 2. Find the flaw. I'm showing you a flawed sample paragraph. A student writes, center is negative g, positive f. Stop right there. Did you catch it? The flaw is the sign on the f. The center is negative g, negative f. That is step 3 in action. Execute analysis with clear working, ensuring absolute accuracy with signs. Okay, final one. Challenge 3. Speed writing. You have 30 seconds. Mentally draft a perfect Peel response for finding the radius if g is 2, f is negative 3, and c is negative 4. Go. Point. State the formula. R equals the square root of g squared plus f squared minus c. Evidence. Substitute the values. R equals the square root of 2 squared plus negative 3 squared minus negative 4. Explanation. Simplify it. That's the square root of 4 plus 9 plus 4. Link. R equals the square root of 17. Boom. Time's up. That is the success sequence executed perfectly, capturing every single mark available. As you head back to your past papers to practice, I want you to remember the 3 absolute rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application. And number 3, time management matrix. Following these steps ensures your working out is as efficient, precise, and fast as an F1 pit crew. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.